Hi, David. Hi, Matt. Great to have you. Today we'll be talking about red teaming, and let's start by clarifying what red teaming means in the context of Gen AI. So, is this a term that can be used interchangeably with penetration testing, or are there any nuances? Matt, would you like to start with this one?
Yeah, so red teaming and penetration testing traditionally are under the same umbrella of adversarial or offensive security. The purpose of each type of testing is to proactively engage with your systems to look for things like vulnerabilities or issues or advanced exploit chains that might exist if a real attacker targeted, say, your application or your network. There is a slight difference between what red teaming means and what pen testing means, even though they really have a similar profile. Red teaming traditionally means that the offensive attacking unit, so that might be a vendor that you've hired or an internal unit, is trying to conduct their testing without being detected. So in this way, the defensive or the blue team has more responsibility to try to detect that their systems are under threat. Red teaming generally will therefore take a lot longer as the attackers are looking for subtle ways into the network or an application or your cloud environment. Pen testing is generally a much more scoped down activity. You are not trying to circumvent defenses in the same way. You're really focused on discovering as broad of a breadth of vulnerabilities as you can. So typically penetration testing is a lot noisier and less focused on the defensive capabilities and much more focused on trying to identify specific issues. So a lot of times pen testing will be called sort of a mile wide and an inch deep, and red teaming will be focused on finding that one path in. Now in Gen AI, I think it's a slightly less clear distinction, but overall, that's how the two terms are distinguished.
I think what would also be interesting to talk about is how red teaming and pen testing are changing with Gen AI. So, I mean, Matt would love to hear your perspective on that too, but I think there are a couple of novelties here. One is, obviously the type of systems that we are dealing with. These are sort of applications built on top of Gen AI models. Would be really cool to uncover what that means. And then one thing that we often talk about is the dynamic nature of how everything evolves over time. Again, both on the model side, but also on the attacker side. And then, I mean, a big thing that we should talk about is the interfaces to these systems. So we're now talking about natural language, English, and hundreds of other languages. We're talking about images, video, audio. I don't know. Is this, Matt? That's probably a question for you. Is this like completely new now, or do the same techniques still apply, or where are we? I guess on red teaming, pen testing. We should probably just say red teaming for AI.
Yeah. So the reason that I think that red teaming and pen testing are becoming less distinguishable, at least in the context of an LLM-based system, is you could imagine that in a traditional application, there are a certain set of people who have permissions to commit code to that app, which would be your development team, maybe your security engineering team. But this is a very small segment of your company. So for an attacker interested in essentially committing code to the application for purposes of, privilege escalation or data exfiltration, first needs to establish some mechanism to assume the privileges of a developer. That changes a lot with an LLM-based system because every prompt, in a sense, is committing code to that application. Now, it's not ending up in, your GitHub repo, but what it is doing is instructing the LLM to act in a certain way. So you could imagine that a system prompt is really what's governing some of the boundaries of what a specific chat application should or should not be saying. And through natural language, as you mentioned, David, you can override that system instruction with a prompt attack. And now the attacker in this case has effectively committed code to that application in a way that the developer wants it to act in one way, and the attacker now has caused it to act in an entirely different way. So this is an accessible route just from the external standpoint of a user. You don't need to spend weeks sort of breaking into these systems to get that level of privileges. So that's where I think things are really being kind of compressed in a way. Now, there's lots of other interesting nuances where some traditional definitions of red teaming still apply. But I think as an attack vector, the ability for anybody in natural language to sort of commit code or rather commit instructions, probably is a better way to put it, to an application really changes the landscape.
I love that. And you asked me about Gandalf, right? And how that fits in. Gandalf, first and foremost, is a really fun and educational game, but it's brought to life with GenAI models that organizations around the world are also using to power their applications. And the reason why that's interesting is because we've got millions of players on the Gandalf platform all around the world that are enjoying this game, and they're using it to learn about GenAI and some of the security implications. And while they are doing that, they're essentially hacking these GenAI systems, or Gandalf for that matter. And one of the really interesting things that we've noticed is when new research comes out, let's say Anthropic puts out a new paper about a new type of prompt attack that can overwrite system instructions, it's really a matter of minutes until someone tries that on Gandalf. And so next to it being a fun and educational game, we can also think of Gandalf as essentially distilling the world's creativity of how people are taking advantage of GenAI systems through natural language in a very dynamic way. And so, one of the big insights that we derived over the last few months is that as OpenAI, as an example, pushes new updates to models, often silently, there are old vulnerabilities that suddenly disappear because they've been fixed. But now there are new vulnerabilities, and people can exploit these models in different ways. And so, to what I said earlier about the novel difficulties of GenAI, we certainly see that as one of them. It's such a dynamic environment. The threat landscape is so dynamic that it literally is changing all the time. And so Gandalf provides us with a great lens into that threat landscape. And then across the evolving number of interfaces and languages and everything that sort of comes with it. I think at this point, we've observed data in close to 100 languages through Gandalf. That is obviously very valuable from a security standpoint.
One of the unique things about Gandalf is it helps us answer a question which feels intractable, which is how do you really search an infinite landscape of natural language to find effective attacks? Because one of the challenges when you think about red teaming these GenAI applications is it's basically made everybody a hacker, but it hasn't made everybody a more effective hacker. So you could spend many weeks or months or years submitting things that seem like they would be bad for the application, asking it to do bad things, but that doesn't necessarily constitute an effective prompt attack, and it doesn't help security teams really gain meaningful insights into their security posture. And so with Gandalf, we're able to see a lot of really interesting and proprietary data around intent and things that work, and that empowers our research team to help be more efficient around answering that question of how do you search the infinite space of natural language, so that when we test a system, we can do so efficiently and actually hone in on things that are effective and actually have the means and capabilities of impacting these systems.
Do you think that's one of the big
Absolutely.
differences, Matt, between sort of traditional software systems and GenAI is that essentially from a security relevant perspective, the input space is now intractable?
Yeah, it's definitely because you can't use traditional systems of, say, writing a deny list to run detections. And we've moved away from that in traditional security anyways to more heuristic-based analysis. But even there, it's a struggle in a space that is all of natural language. And that makes it difficult to also effectively evaluate these two. So it makes it difficult to defend and difficult to evaluate. You know, this idea of like write your own vulnerability is not something that was present, you know, in traditional spaces. That, you know, I relate it to now is like it would basically be have everybody look through a code base and, you know, write their own pseudocode for a remote code execution vulnerability. That's effectively the problem at hand, although it wouldn't necessarily lead to remote code, but you understand it. Like, so you have that on one side is this whole space, but then from the testing perspective, writing your own vulnerability still requires actually producing a harmful output. So just that's where it's on both sides of the coin. It's a really challenging issue. If you're defending it, you have to sort of feel like you're defending against all bad things. And if you're testing it, you have to feel like you want to test all bad things. Neither of those are really possible. So it's definitely an entirely new threat vector in that way.
Sorry, let me just jump in one more time because there's something I have on my mind. You know, Matt, you and I have been talking about, you know, you do this sort of red teaming exercise and then you've uncovered something. So what's next? Like if we assume that the world is moving so fast and, you know, you always get to work with like different model versions and, you know, things disappear, things appear. So like, what do you do? Now I uncover something through a red teaming exercise. How is that still valid tomorrow?
Yeah. Plus, I think that, you know, with language, you have like finite set of words and infinite number of messages that you can create, and the same applies to attacks that can happen. So even if you end up at a point at which you know you've discovered something, you know what to do with it, it doesn't mean that tomorrow there's not going to be like 100 different issues that you're gonna be faced with to solve and to protect against. So how does Lakera approach red teaming differently, and what makes it effective for securing GenAI applications?
Do you want me to take that one?
Yeah, why don't you take that?
Sure. So I think it relates to what I was just talking about, which is from the testing side of things, you need a way to focus in on high efficacy, highly salient prompt attacks and strategies. So things that we see that are not highly effective are just sort of using open source data that you might find in a, say, Hugging Face data set. Those things are useful to test with to make sure that your ground bases are covered, but models are trained on that. Everybody has access to it, and it doesn't give you a lot by way of actionable insights. So Lakera's approach really is rooted in our threat intelligence database, which is always expanding. It's based on real world attacks. So effectively, when you come to Gandalf and you play the different levels and you use the different techniques, these represent real prompt attacks that have efficacy. Whereas we see a lot of these sort of open source data sets and techniques even, which are sort of straightforward and naive. So we have that threat intelligence database to pull from, and then we work with research institutions and some of our startup partners who are experiencing or testing or trying to find these cutting edge techniques. And so I think applying those two together gives us a really unique insight into the strategies, the techniques, and the data that focus on things that are going to be highly salient and actually impactful if somebody's able to exploit them in your system.
Love that.
What do you think the future of red teaming is going to be for GenAI? Which direction this is all evolving?
Lakera red teaming.
I think
I guess there's something to be said about. I mean, if I think further out, it's like agentic red teaming. That means red teaming agents, but also using agents. Smarter ways to explore the infinite space, making sense of context and history, and different types of information you want to take into account. multimodal. We talked about the intractability of text, but how does this even look like when we have all sorts of other modalities like videos that we pump through these systems? I don't know. These are two things that come to mind. Matt, anything for you?
Yeah, I think the paradigm shift is going to be away from conversational applications, which we see today, and those are still going to be really important. That's sort of the front door for a lot of businesses in terms of customer service or knowledge hubs. And so being able to exploit a system like that can be quite damaging from usually from a brand standpoint, or there's lots of data and privacy concerns, right? If you can exfiltrate data from those types of systems, that can be really harmful. But where there's going to be a big step is when these agents and the models that are powering them or that they're interacting with have the ability to autonomously take actions in an environment. Eventually, this will probably, in a way, simulate like having little specialized employees working for you or working for your company. And so you could imagine if an agent has permissions to maybe one day write to a database. That seems like it's pretty far-fetched right now, but as we use these for more utilities, you can imagine that then an agent with that level of permissions that's compromised could be much, much more damaging. So I kind of think about it like the shift from traditional on-prem networks to the cloud, where there was just a whole new set of vulnerabilities that were introduced from sort of the Lego block building nature of the cloud. And I think agents will have a similar profile where you're sort of building Lego blocks of agents that can work with, and then ultimately, if you can exploit it, against each other. So that's where I see it headed. I think we're sort of in inning one with the conversational apps, but it's still a really important question and landscape to be in, because whatever's happening today is just going to be advanced, in the next year or two.
So how does Lakera Red fit into this picture, and how does it create value for clients?
Well, I think Lakera Red right now helps you really answer the question of how resilient is my system. And when I say system, I mean the LLM powered application, the Gen AI application, your conversational agent. How resilient is it to an end user or somebody, an attacker who's submitting sort of advanced adversarial attacks against it? So it lets you know where some of those failure points might be, and it highlights gaps that you might have in your defensive system. So David asked a good question earlier, which is, you need to identify where these things are, because they can lead to damaging outcomes. And then you need to have a plan of how do you fix it. If you want to participate in the AI space, if you want to enable your business in that way, you need to answer that question. And so I think that's where Lakera Red helps really in identifying these issues effectively. And then on our other side, which is our flagship product of Lakera Guard is really answering that second part of the question, where system failures are identified. How do you detect and prevent those in real time? Because there's no guarantee that you're covering every single issue that's possible in the landscape of natural language with a red team. So you really need kind of both sides of the story.
Thank you guys so much for this conversation. It's been really eye-opening and really educational.